Hello students, welcome to my YouTube channel. My name is Kiran Pothina and in this channel I will be solving important second PU mathematics questions to help you prepare effectively for your board examinations. Today I am starting with an important 6 marks question from linear programming problems and I will explain the complete graphical method step by step. If you have any questions or topic request, let me know in the comment section. Now let's begin. They given maximize z equal to 3x plus 2y subject to two constraints they given. So when it comes to the solution, first I will write the given objective function, that is z equal to 3x plus 2y. Okay, so and I will also write the constraints here. So what are those? Given constraints are, constraints in the sense they given a linear inequalities, these are only considered as constraints. So the given constraints are, first one is x plus 2y less than or equal to 10 and one more, that is 3x plus y less than or equal to 15 and then x greater than 0, y greater than 0. So here first the inequalities will convert into equation. So first one I will write x plus 2y equal to 10 and this is 3x plus y equal to 15. So after writing inequality to equation, we have to draw a table so that we will find the points here in order to plot in the graph. So x and y. So I will take x 0. When we take x value 0, what about y value? Y will become 5. Similarly, when y equal to 0, x value will become 10. So similarly for this line equation also, we find the points. So how to find the points, I will tell you once again, you see. So first we will take x equal to 0. When x equal to 0, so what you will get is y value 15. Similarly, when y equal to 0, x value will get 5. So these are the points get. What are the points we got? Points are 0, 5 and 10, 0. So here points are 0, 15 and 5, 0. Now after getting the points, understood now, first step is after writing inequality, write to equation. After writing equation, substitute x value, you will get y value. Substitute y value 0, you will get x value. Note down the points and then we will do checkpoint. So this is must and should and the main important thing in this question, that is checkpoint. So for the checkpoint, we will consider 0, 0 is our checkpoint. Consider 0, 0 as our checkpoint. So what is the use of this 0, 0? That 0, 0 we will substitute in this inequality. That is x plus 2y less than or equal to 10. So in the place of x 0, in the place of y is also 0. So what you got? 0 less than or equal to 10. So that means true or false we have to mention. When it is true, we will write shade the region towards checkpoint. This thing also compulsory mention, because as it is for 6 marks now, we need to mention all the necessary things here. So whenever we get true, when it satisfies like 0 less than 10, we will write towards the checkpoint. Next, for this also we will do checkpoint. So checkpoint we have to do all the cases whenever they given linear inequality in two variables x and y. If they given, we will do checkpoint. So for this also I will consider 0, 0 is our checkpoint. So consider 0, 0 as our checkpoint. Okay. So we will take the inequality here, that is 3x plus y less than or equal to 15. So in the place of x 0, in the place of y 0. So what we'll get here? 0 less than or equal to 15. Again we got true. True means as like this. This is shade the region towards checkpoint. Shade the region towards checkpoint. Okay. So first remember these 2 points we will draw in a graph. First one is 0, 5, 10, 0. We'll move to the next sheet. So first line points are 0, 5 and 10, 0. Okay, so we'll draw the graph. Okay, so this is y and y dash. This y dash only will consider as x equal to 0. This is x dash and this is x. This x axis only will consider as y equal to 0. So, and this is our origin. So I will take the points like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Say according to our requirement, we will take the points. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Till 15 we have a requirement, so I have taken till 15. If any more values like high, see here 5 and 10 are there, no? So like that I have taken like 1, 2, 3, so on like that. If any big numbers came like 15, 20, 30, 50 like that, then you can change like 5, 10, 15 like that you can write, or else 10, 20, 30, however you want you can write, but based on the number size you can write. Now, the one more important thing in the graph is writing scale. So that is on x-axis, 1 centimeter equal to how many units we have taken for each. So we have taken one only. So I will write 1 unit. Similarly, on y-axis also, 1 centimeter equal to, again I have taken 1 unit. Okay. Now first line 0 comma 5. So this is 0 comma 5. Okay guys, this is 0 comma 5 and this is a 10 comma 0, 0 comma 5, 10 comma 0. So I will join these two first. Okay, so this is the first line. So the line equation also I will write, because we won't confuse when we mention that x plus 2y equal to 10, and I will write the points also. This is 10 comma 0 and this is 0 comma 5. We have to mention everything, line, equation name as well as points. So what is our second line? So that our second line is, so 0 comma 15, second line points are 0 comma 15 and 5 comma 0. 0 comma 15, 5 comma 0. So let us join these 2 points. Okay, so what is this line? This line name is 3x plus y equal to 15. So for both the lines, checkpoint we done, checkpoint is very much necessary. Checkpoint what we got, or both we got true. True means what? So this is our checkpoint, right? This is 0 comma 0. So towards that only we need to draw arrow mark like this. First don't draw like this big lines, don't draw. Okay, so because first we need to identify which is the common region, so then we can identify easily. Similarly, for that red line also we got the checkpoint true, so towards the checkpoint we need to draw. Now identify, here we got 3 regions: 1, 2, 3. Out of these 3 regions, which region having both the common region like red and green? So second region we got both red as well as green, so we'll consider that is our feasible bounded region. Okay, so now we have to shade only that part only. Okay, so I will shade this. So we will shade only this part. Okay, like this you can write like boxes, or else you can shade with pencil like that. Okay, so now after that I will mention this as feasible region. This is also very much important. So the common region whatever we get now, that we will consider as feasible region. Now after finding feasible region, for that region what are the corner points that we have to mention compulsory? See what are those? 1, 2, this is one more, and this is one more. So total 4 corner points we got. So I will mention. So this is 4 comma 3 and this is 5 comma 0. This is 0 comma 0 and this is 0 comma 5. See here if you observe, we have two more points like 10 comma 0 and 0 comma 15 also, but we won't consider these as corner points, because wherever we get the region, those corner only we have to take. We should not take 10 comma 0 and 0 comma 15. Understood? So only these four. See, after finding, so I will mention with that, with the names like this, like this is A, point A, B, C and D. So like that completely we have to write that graph. In that graph what we have to mention is line names and points and where is the feasible region, and corner points we mention with A, B, C, D, like that. Now what we can write here is closed figure, closed figure A, B, C, D, A is our required feasible region, is our required feasible region. Okay, now so now we need to draw a corner point table, corner point table. So this is also very much necessary, because based on this only we will get the maximum value or else minimum value. So how many corner points we got? So we got four corner points. I will mention all. So this is 0 comma 0, this is 5 comma 0, and this is 4 comma 3, and then 0 comma 5. So here order is not important like mentioning like A, B, C, D, but anyhow you have to take all four. Order is not important. Okay, now we'll substitute all this. So here first of all x value is 0 and y value is also 0. So we got 0. Now here this is 3 times of 5 plus 2 times of 0, which is 15. Next this is 3 times of 4 plus 2 times of 3. So which is 3 fours 12, 12 plus 6, here we got 18. And this is 3 times of 0 plus 2 times of 5. So here we got 10. Okay. So as it is your board's exam, we have to present it neatly. Okay. Now, so here the one more important thing is, see after getting the values like this, what they asked here, observe the question. So they are asking maximize. Maximize means maximum value we need to find out. So what is the maximum value out of 0, 15, 18, 10, 18, right? So what you have to do, that box you highlight. That box you highlight. So that whoever will correct the question, your answer sheet, so they will easily identify that what is the maximum value in that. So after identifying, just you write like maximum anta. So now our conclusion, therefore the maximum value of z, therefore the maximum value of z equal to 3x plus 2y is how much we got? 18. But at which point we got 18, that also you have to write 18 at 4 comma 3. Okay, so like this we have to write. Understood? See, once again we will revise. See, first from the given constraints we have to convert into equation. After equation, substitute x0 as well as y0. You will get the points now. After getting the points, you do checkpoint. For checkpoint, maximum every time you will consider like 0 comma 0, but there is no compulsory like you have to take only 0 comma 0. But why will take 0 comma 0? But for the simplification it will become very easy. Okay, so we'll take 0 comma 0 as our checkpoint for these type of lines. Now if you get true, then we write like shade the region towards checkpoint. If it is false, then we'll write opposite to. Okay, so this is about the first phase. Now when come to the next sheet, so we'll substitute the points on that graph and we will write the line names, point names as well as feasible region, and we will mention the A, B, C, D, A like that. That we'll write like closed figure A, B, C, D is our required feasible region, and after that we'll substitute in that objective function. So this is called as objective function. The objective function will be useful only at this corner point table. And then we'll identify if they ask maximum value. If they ask minimum, then we will identify like 0 anta. Okay.